How's it going, everyone? Eulier Gonzalez, exactly, barely here. Uh, what happened is that right now I don't have any lights. The handyman, to be honest, I didn't talk early on to the handyman to actually help me to put some lights on my room. But in any case, here we are. What matter is what we're gonna do in this video, which is building this particular project of word game. So after we went through the model 0, 1, and 2, and in the model 0 is just to understand about based on science how you can learn, right? So one of the things is that actually is doing the stuff and blocking and interleaving, aka, well, so safe space for dedicating your attention to a particular topic, let's say an academic hour, and then you switch to another topic, of course, that is related to, and then go back. This is one way of how now science has show that people that do this, well, actually increase it is memory, it is understanding of this, and the other is that via error corrections. And the thing with error corrections is that you have to be present in the moment and put yourself in awkward situation or in awkward put yourself in those awkward situations, measure the risk that you're gonna take, all right, and through the errors that you made along the way, you're going to now adapt your mind, aka via neuroplasticity, right? So new circuits are going to be now rewired, but and it is based on the truth of that matter, and anything else is like forgot, right? So for example, like saying that, hey, socialists, this time will work. All right, good luck, go on. So but in any case, and then the model 1 we explore about is what React is, who made React, and what was the problem that React had at that moment, or the problem Facebook had at that moment, to actually make now React a powerful and very compelling and convenient library that allows us to manage these particular states. And how you can create now a React application from the scratch. What React is doing behind the scene at the end of the day is creating now a user interface. It's like a very thin layer on top of the HTML elements. And not only that, because now you can also use that not only for the web but also for the mobile applications, as well as the mobile application, and the, how do you put it, and also for the WebLG, for 3D engines or 3D rendering stuff, using the WebLG, the web graphic library. So each one of them has their own directive that allow you to now is define and target, aka the render is those user interface in their respective platform, whether it's the web, the mobile with React Native targeting iOS or Android or Windows phones, or even the WebLG. All right, but in our case, we're gonna focus solely on the web. All right, so that's why when we use now React and React DOM, this nice little thing wrapper around these HTML elements, that describe now is the state of that particular user interface as a JSON anytime that is creating that particular React elements. That's what it's doing behind the scenes. Okay, and as we explore now how tedious it is to define all of these user elements, aka React elements, especially when you have to create now lists of elements or forms of elements, okay, it can become very tedious to write all of that. This is why we have now JSX, which is this language that combines now the HTML and the JavaScript syntax that help us now to focus on what we really care, which is managing the state. All right. So as we explore now what is this JSX, what is the difference with HTML, all right. So JSX, we can have the main difference is that sensitive tags, all right, and also is the sensitive attributes. You now they have to define is this as a camel case attributes in events, and also is some exceptional keywords like HTML4 or the class name, all right, and also how helpful is for us to see this JSX in to understand why JSX is now so powerful, because you don't have unlike template engine. When you compare now JSX with template engine, you don't need to actually create your own mini language to rendering elements or to conditionally render elements here. So for example, like Blade in PHP with Laravel or Liquid with Shopify, right? So it makes a lot of sense that we can now reuse is a lot of this logic, a lot of this knowledge from JavaScript when we need to define any logic. Okay, so that's great, that's powerful. So because this way of writing this kind of applications like components, right, so you have now is the HTML, CSS, and JavaScript prior to React, but now in React we have now HTML and CSS, and also HTML and JavaScript, and also CSS. So because of this way of writing these components, these user interfaces, so we have now the component architecture, or the component way of creating this user elements, where here we have now is the combination between the JavaScript, HTML, as well as CSS, all right? And because of this, what is the anatomy of these components? And that is, well, we have is the the component in itself that we can define as a function, it's a JavaScript function, and this will now receive some properties at runtime. And this is why it's important, I make a quick segue here to understand that JavaScript, at the end of the day, you need to understand how the things work, similar for CSS and HTML. And a lot of people might say, hey, you don't need to learn about that because they are going to be now generated by AI. Good, fine, but at the end of the day, you need to understand when something crashed, when something went wrong. And that's when now the experience, the expertise, and especially the understanding of how the things works and how you keep up the pace with learning all of these different technologies and their new advancements and each the ecosystem, well, that's the whole. That's helpful. That's useful. That's practical in your day-to-day life as a software developer in the web. But in any case, so as I mentioned, is the components and the anatomy with props and children. And children is now as a part of the HTML attributes that allow you to define now is what will be is the nested elements in that tag. So you can use as children, or you can use as now, or you can wrap that content between the anchor tag. So I wasn't well aware of that. I do think that's quite even revealing and interesting, because the people that make React is actually not reinventing the wheel. They're just reusing a lot of stuff, and they just has been exposed daily to this reality. So so now that we know how to define our components, what our components will be, the anatomy of this, we also look at another helpful components like React fragments that allow you to define is content without creating is a root element. So it's going to now React with these fragments, insert this kind of content at that particular point in the DOM. So that's great because we avoid polluting the global scope. And when it comes to now rendering element, which is the task that no matter where you are going to work, the two most important and most common thing that to do in any programming, especially on the web, is rendering a collection of values and collecting data from the user via forms. So first things first, well, look at what is the most common thing to rendering a list of elements. Okay, and here we look that we're going to use is the JSX expression, aka the JavaScript, as a way to render collections of elements. So because now when you're doing that, React doesn't have a native way to identify uniquely each one of those elements, especially when you're rendering a collection of them. Well, that's why we use now a key, which is a property from each one of those elements to indicate, hey, React, hey, this is a unique element. All right. And we're gonna see that later on in this course, and also in this recap that I'm doing, why the key must be unique. What are the alternatives to generate those key uniquely right now in 2025, and then when it comes to show conditionally elements, we can go is at least right now is for we can take 3 strikers. So the first is going with the if statement with the early returns, all right. The other is with the ampersand, the double ampersand, all right. You do this is via so we use the if statement or if else statement is, for example, when you want to now show is an authentication form. So for example, hey, if the user is authenticated, I want to show now this particular document, or if not, I do want to show now this specific document, right? And this is how you can now play with this if statement, and a very common way to do so. We can also define is, for example, multiple buttons, okay, that based on a particular color, on a particular size and dimension, aka based on a particular style, we can render that, right? So we can define all of these cases, bottom use cases. There's some trade-off in doing that or not. But the thing here is that this is the first way of how you can now define conditionally elements. All right. So you can do is via the if. All right. You say, hey, I want to now render is this element, and then return this document or this subset of React elements when the user is login. If it's not, well, I do want to show now, for example, is the login page or this subset of React elements that is going to render is the login, right? Another is the double ampersand that is helpful when we need to define is conditionally elements inside of our templates, inside of our returns, right? So this will now act like a guard to conditionally render this, so on and so forth. We can also use now this ampersand, double ampersand, or the logical N, to show now features based on a particular state, right? So the other is, and what is the trade-off between the if and the ampersand? Mainly is that with the if, we can narrow our view is to show is a specific two elements, so we can actually nest it, that if else is else. But with ampersands, we can now is also define which path we want, which user experience we want to show to. So which user experience we want to show, as well as which feature we want to show to specific user, right? I do think that this is quite compelling. We can also use the ternary operator to do so. The ternary operator is helpful because it now helps us to deal with the if and else statement. Okay, when can I deal with these scenarios? So for example, if I want to now is show features to on the template, right? Show features, specific features on that template to login users or not, right? Rather than showing a complete page or to a complete subset of elements that made a page, right? So this is the nuance here of when and why can we use this kind of stuff. And it turns out that the other thing that we need to know, especially as we write our React application, is that how do we now style these elements, right? So this is why we have is CSS in models, which is something that is provided by some model bundlers like Webpack, okay? Where by defining is a CSS style with their selectors, it will now help us to access to each one of those selectors as a JSON in our React components. So this is that at runtime, each one of those selectors have now a unique identifier that is using is the name of the component as well as a hash, follow the name of that selector, and that is going to now define when the application is bundled up and ready to be served or is delivered to the client. So when you inspect that, what happens is that the elements or the CSS inline has that now particularly name of the component as well as a particular hash and the name of the selector. This is to uniquely identify now each one of those CSS selectors per components. So this is actually true encapsulation of CSS. So there has been other alternatives to do that prior to React, which is, for example, is certain methodologies like bend methodologies that require certain disciplines to developers to follow. For example, is that, hey, we need to follow is this particularly name convention, block, models, and elements. But the thing here is that it can be quite cumbersome because you might sometimes have the same name, or name can have the same. They might be quite. You sometimes might have is name collisions, and you don't want to have them, right? And not to mention that also is required that a certain discipline to developers. And if you as a developer doesn't fully hardly understand, not believe, understand the reason why you're doing a practice, it is very hard for us to actually help us here, right? In doing so. So in other words, it is very hard to get yeah, did I lose my mind? It's very hard to get it's very hard to get the discipline when you're doing something if you don't for example understand why you're doing in the first place. But if you genuinely don't understand that. So, but in any case, that's the part of the methodology in CSS that we have right now. And it turns out that a CSS model is the convenient and compelling way to actually include now CSS in our React components. This is only this is the recap of module 1. And in module 2, we say, hey, let's go to now explore about the state, working with the state. And again, because in the React, since this is now a thin little wrapper around the UI components, the way how do we respond to events without it, plain HTML, is by or getting that elements and attach an event listener when a event happens to that particular element, and pass now a function to that, all right? Or now execute a function via a event handler, all right? Directly in that HTML. So this is the two way of how we can now add events in our HTML. So because of this, React way doesn't actually behave in this way. So the way to do this is, hey, if you want to now add interactivity to this, the React way is to now pass a function reference to that handler, okay? And it is React that is going to trigger that when the user interact with that element. So what happened here is that we are delegating this event handling mechanism to React, okay? And you might like it or not, all right? But this is what it's doing if you're using now React, right? Unlike, for example, with jQuery, where you can now explicitly access to the element and attach the event listener, so on and so forth, you know? Okay, so this is it for the React. especially when adding interactivity to the user and detecting interactivity to the users. So when it comes now to provide to response to user event, when it comes to now detect interactivity, okay. So for example, is a counter or update now a particular element into the DOM. This is when now the user state kicks in, which is a particular hook that what allow us to do is attach now is that particular event, a particular state to a value, and when a change happens, we can respond that by setting that state. All right. We can also is define this initial value as a function to say, hey, we do want is to run this function for the first time when this component is mounted, right? So this is when now the life cycle of this particular hooks kicks in. And this is why it is important for us to understand this particular life cycles. How to do that, when to do that, and then you get it, right? So the point of the React, especially here with the use hook, is the user state, is that when the user trigger that state, all right, so React will know which components trigger that update state, and then is going to now render, aka call that component who triggered that, and if that component inside of the return keyword contains more React elements, it will gonna continue to call all of them until there is no more React elements. In doing so, it's going to create now this new snapshot of the React state, aka the virtual DOM, okay, that now when the re-render is end, when that evaluation is over, now React have these two structure, these two snapshot of your UI. So the rendering is also now spotting the difference among these different snapshots, and on the commit phase is going to apply now the bare minimum edit to the DOM, which when that happens, the browser detects a change and then repaint your UI to match that. This particular process of describing this, okay, is now important, especially if you want to have clarity of what you are doing. And I do think that, you like it or not, in any endeavor, you're going to develop this as you do this, right? So you can try to memorize this, but I don't think that's it doesn't work. It doesn't work. It doesn't work. It doesn't work. You can try to memorize all of this, but if you don't understand, if you don't make the relationship of what, all of the things that you are doing in mapping, why they are connected, you just memorize stuff. You know, do you memorize stuff, or do you know the trade-off of all of this? So there is important. There is also another important thing to talk about because we mentioned about rendering and painting. So rendering here in React means something different from computer graphics. Okay, where you take now an unprocessed raw input and you generate now a ready to be used output. Okay, but in the case of React, this means is the spotting the difference among the snapshots, and then update the DOM. What it means is spotting the difference among different snapshots. Right, that's what this renderings means. And the painting is, well, is something that now is the browser, when detect those DOM attributes or properties or content change, is going to now pass through the critical rendering path, or AKA is a process in which they're going to now calculate is the layout, and then it's going to calculate the layout, which is part of the layout phase, which determines the position and the dimension of all of these elements. And once that is done, now it passes through, depends on the browser engine, of course, it's gonna pass through a composite layer, and finally a painting layer, right? And the composite layer is, you have now several of these layers. It's going to now figuring out what will be the end result to paint and to show to the user. So so yeah, this is actually tying the knots here, or as the meme suggests, it's like, hey, is everything connected? But yeah, that's the whole idea of actually making this quick recap here. Now, another thing is that as I look at the hook and the core loop, right? And also is that how now these updates happen asynchronously, aka in the next render. And it makes a lot of sense to actually happen in that way, because if you can imagine that all of your state updates now are synchronously, it'll be very inefficient to do so. So another thing is that as I look at working with the state, and also another common thing which is working with forms, and that is, hey, how do we now, for example, when you want to now detect that a particular input change, you want to capture that. So, and it turns out that form, because it's the most, and to me is silly that this is a topic that a lot of people dread about or hate, but this is what it is, man. It's like whatever you hate ends up owning you. So it's like hating why the sun is rising and goes down, or for the rain, it's I don't think this is sincere. I don't think that the hate is sincere. It's just an emotion, just for the sake of just to hate, and that somehow give you some meaning or sense of belonging here. But the thing here is that it doesn't work. Hating something for the sake of something, for the sake of hating, it doesn't work. It doesn't work. In any case, so since forms is this particular topic that anytime that we're asking a question here. So anytime that you want is to now, for example, detect that a particular input change, how do you now update that? And if you now, for example, define a variable for that, or you now don't want to React now take care of that, let me scratch that a little bit. If you, the question is, if you want to know that a particularly, okay, this is the question. The question is that, what you have to do when you want to update the input of your forms, right? So how you can react, no pun intended, to do that. So, and it turns out that there are several ways to do this. One of them is that don't let don't let now React take control of that, known as uncontrolled input. So by wrapping that in a form and then in a label and then all of its input and so on and so forth, and then only when you submit to that, you're now going to collect that via the form. Okay, this is one way to get it, or the other is that by controlling the input. So you're now telling React explicitly, hey, I do want you to now take control of that, and then I want to now do some validations that it needs. So there are several libraries out there that are heavily used on this kind of stuff. I don't think that you actually need them. If you want to save your time, maybe for some applications, right? So you don't have to rewrite your own logic, but most of the time you don't actually need to work with them, unless you are creating now a multi-step onboarding form, so on and so forth. And nevertheless, it's something that you can now, with the current state of React, handle that by yourself. So for example, with the use reducer, for example, right? So in this case, with the use state, by defining the user state and wrapping that with the input, the way to do that is by, hey, when this change, on change, I want to set the setter function here as an inline function, and when that change, I want to now React update this component with this particular value at that input. So this is quite my banding stuff, right? But you can actually do that by your own. We look at that for inputs. It's quite straightforward, right? Most of the time, those inputs actually have the same pattern. But for example, in the case of select or text area or radio buttons or checkboxes, so the logic now change a little bit. So, for example, is that, hey, what happened when you do want to know this data binding? Okay. Other frameworks, so for example, like Angular and Vue, they provide now you a specific directive to do so. But here in React, we don't have that. And in fact, it is one of the reasons why I find that out, because I started my journey with Angular and then with Vue. I find that out very, very, very hard to get it with React, but because I didn't understand that. And if you want to now do this data binding for all of these different input that I mentioned, not only inputs, but normal input, okay, but also for selects or text area or radio button or checkboxes, okay. So React say, hey, let me now is define a common patterns to actually bind this data across different inputs. All right. So except in the case of input checkbox and radio button, right, where you are going to now have to check the value by verifying that, via the check. Okay. For others, like select or text area or inputs, okay, input color, tell, date, so on and so forth. So you have now this particularly common pattern for, and I do think that is very, 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 very interesting. Absolutely, interesting and useful to know, useful to understand. So, on the form, all right. We also look at a particular way of how to work with that. Also, we skip this particular section of range utility and how you can now use or render a collections of elements with that. But this is now with the forms, right? And also is that how you can now is well, collect data from the forms via the onClick parable or the onSubmit. So in our case, use a forms and especially the onSubmit to actually is capture that data as it is. So here the defining is this run search and run search, right? Run search is being received here as a function that is going to be executed by the time that now we submit to that. So we here now are preventing is the default behavior that form has, because this is way back to React land or even fetch API. Exactly. XML HTTP request before JSON. And if you wanted to make a request to a server, like when fetching search results, you couldn't request only the data. You needed to request a whole new HTML file. Essentially, the user will be redirected to a new URL, and the server will then render a template into an HTML document using send with the data here. So because the default behavior with this form is that, well, it's going to now do a round trip. It's gonna submit or make a HTTP request to the server and then get via, you're gonna make an HTTP request to the action to the action property that describes the route where it needs to go to the server to fetch that document and render. So to prevent that behavior, we use that event.prevent default. And I do think that's quite interesting. And also, the other is that understand the difference between the props and the state, something that I'm quite familiar with. And now working with complex state here, right? And why it is important for us to always is recreate the new state from that. And if you think about this, right, with this mutation box, right, is because since React here, or since JavaScript doesn't have a way to identify if complex states now are different, okay? So for example, if you want to compare now two variables, let's say object one, let's say, or the user, let's say user, right? Say user, and this user now is the name, which is SWR, and this also have now, hey, wait a second, oh, it won't allow me, oh, it allow me, okay, good. Age, 35. Diggy. Let user name evaluate age 35. What's next is the name, age. Yeah, what's next? Zip code, right? I think it is. And not only that, you might have is some nested data to say, hey, this is address, right? Typically, the all trusty one. Hey, this is address, right? And in this address you have now this, and you have the street name, right? Say La Valle. The hell is that? Well, you'll figure it out. So what happened here is that if you, for some reason, you create now a reference to another object, right? So user one, that it has now a reference to this. And then later on you say now, hey, user one here, dot name, and say now this will be now is John, right? It'll be now John. The question is that how do you know that user is equal to user one? It's like, holy, what is this? How is that possible? And not only that, it's like the naming in itself changed, aka it mutate that. But I didn't want to do that. I just wanted to is update the user one, and then I pass that here, right? So this particular problem of holding reference of another objects, and if those objects now change, right? Online, for example, now user one, right? Because anytime that you now have a reference to another object, what happened is that all identifiers, aka all of these names, all identifiers that have a reference to that value, complex value, aka object, all right? If that object change, the reference are pointing to that, right? So this is something that is tricky, because how you then can keep track of when a state change happened here. Right now there is no built-in mechanism to detect that unless with proxy. But back in the 2011 there was no native solution to keep track of that. So React, what it does is say, hey, anytime that you want us to now mutate or define a new state of this complex object, please return me now, or give it to me is now a new object from that with this new state. So this is fairly trivial for a single object. But what happens when you need to have to modify is nested object as it is. This is when we have now solutions like IMER, right? That IMER say, hey, let me actually is the word for, it's a German word for always. So now let me actually is simplify things a little bit and say something like this, and say, hey, if you do want to now update nested properties, all right, without having to do all of the boilerplates. So I'm say, hey, I'm going to have now like different stage or different places at my desk. All right. So one of them is a current, the other is a draft, and the other is the next. Right. So here you can now is mutate, quote, the state in this JSON, like in the JavaScript object way. So again, this is something that goes beyond the scope of today's video, but I do think this is also quite revealing in order to understand that that is quite convenient when you now is wants to do that. But in any case, so yeah, this is a very good segue that I took here. So then I look now at the dynamic key generation, especially when you want to render collections of values with key, and then you don't want to use now the index because if for some reason your collection of values now change, all right, somehow the side of your collection of value change, and then you add new values to that, so your elements or your key might be in a undesired state. So if you can imagine that you have now rendered 5 elements, right? Then you somehow now is remove one element, and then you have now 4, and then you add a new one element, and then you have 5. So these new elements shouldn't have 5 instead. You have this 6 because you remove the previous elements, and then you now add this new element. And this is when these kind of things actually be in this wonky state. So the TLDR of this is to right now use this built-in browser web library crypto that allows to generate is these random numbers. So we can use this now is crypto get randoms values. No, but it's crypto random UUID that is going to generate some random numbers based on this UUID, which is universally uniquely identifier. There is a paper that is back here. There is now in the version 4. I do think that the way of how this is generated is via the topography, cryptographic topography. Cryptographic topography, bro. Holy hell. I do think it is. It is. The version 4 is randomly generated. As in other UUID, 4 bits are used to indicate the version and 3 bits to indicate the variant. And now it's in version 7. Holy hell. Are designed for keys in a high-load database and distributed system. That makes a lot of sense. Begins with 48-bit endian Unix epoch at timestamp with approximately milliseconds granularity. The timestamp can be shifted by any time shift value here. And version 8 only has 2 requirements. The variant bit has to be 10th, so the nimble containing the variable must be 8, 9, 8, or B. Oh, in hexadecimal. The version nimble have to be the value of 8. Those requirements tell the system that this is a version 8 UUID. The remaining 122 bits are up to the vendor to customize. The difference with version 4 is that those 122 bits are random, but the 122 bits in UUID version are not, because they follow vendor specific rules. That is to me quite interesting and a very interesting segue of understanding why and how this universal identifier works. exactly how this UUID determine it is uniqueness. It is quote quote uniqueness value. Exactly. What is the mechanism? Is used 122 random bits out of 128 total. Relies purely on randomness. The probability of collision is astronomically low. It relies on purely on randomness. Use cryptographic hashing SHA-1 for V5 and MD5 for V3. Unix time in millisecond plus random bits. Combined time ordering benefit with randomness. Why they are unique enough? The key is probabilistic unique rather than absolute uniqueness. Massive number. Because you have now a massive. Is 2. Holy hell. Is 2 power 128. 340 undecillion possible values. Undecillion? The hell is this? Undecillion? What is an undecillion? The cardinal number equals to 100. Holy fuck? Undecillion. 36 zeros. Holy hell. A number equal to 1 follow 36 zeros. Holy hell. 36 zeros. Undecillion. Oh my god. Okay. Use 122 random bits or 2 power 128 values. So the possibility is 1 followed by 36 zeros. Undecillion is like what the French does is like 12 twice. Thrice. Exactly. It's like thrice times. Jesus fucking Christ. It's like thrice time. God damn it, bro. Yeah, it's like thrice. Yeah, god damn it, bro. It's like thrice time. Yeah, the key is probabilistic uniqueness rather than absolute uniqueness. Massive number space, 2 power 128, 34 undecillion possible values. Birthday paradox. You need to generate is like how is okay is big. Holy hell. But this crypto random UUID, this crypto random UUID, uniquely identifier. This feature is available only in secure context in some all supporting browsers. This feature is available in web workers. So crypto is available in web workers, but it's using is the version 4, which means that it's going to generate is one number out of the on the zillion. The hell is that, man? On the zillion, aka a one followed by 36 zeros, aka thrice billions. Exact, not thrice billions, not 12, Millions, billions, trillions, thrice trillions. Jesus. Mm. Mm. Parameters, return value, a string containing a randomly generated 36 character long but this is exactly is generated now this character long, a 36 character long v4 UUID. But out of that, and here is going to describe is what is this exactly. Interesting. The random UUID method generates a new version for UUID and return it is namespace specific string representation. Exactly. Generates a new version for UUID. Alright. Set the two most significant bits, 6 and 7, or the clock high. But it's actually is based on that number that is generated. Alright. I do think it's describing is this the version number is most significant. Well, in any case, based on that, it's gonna return now a specific string representation of that. Holy hell. Namespace specific string syntax. So it generates that. Oh, okay. So it generates that number, that long number, right? That has now a string representation of that. Holy moly. Okay. 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 So for these cases, might work. Alright? But when you have to deal is with long numbers, I don't think that actually something quite need to. Generating UUID in JavaScript with window.cryptorandom here. I wrote 20 books to help you become a better developer. JavaScript handbook, TypeScript, CSS handbooks, Node.js handbook, Astro HTML, Next. Download all of them. Git Masterclass, Astro HTML Masterclass, Solopreneur Masterclass, TypeScript Masterclass, React Masterclass. Join the waiting list, AI Workshop, and Web Development. I'm using Astro for that. Yeah, you on the bleeding edge, bro. Okay. Interesting. Mm. Ah, Montessori. Ah, they okay. Mm. Mm-hmm. Montessori and using the Alpha School. Mm-hmm. Okay, so we get into another rabbit hole that is not part of this. Mm-hmm. Anyway, um, but yeah, we get here. Okay, we get here is based on that generation of random unique values. Anytime the unit for somehow needs to add a new elements to that, right? And the other is a lifting and stay up, which is pretty straightforward. I know what I have to do. Especially, I need to indicate that at which position into the DOM I need to render this component, right? So the further down is the component, the less likely is to be affected other prior components. So in other words, the further we push the state, the better off will be for performance. And then the component instant and the state management tools. And here a quick intro here, right? Because this is a question that is asked a lot. State management tool. So here's one of the most common React questions I have been asked. Should we use something like Redux to manage global state for us? Or is React capable enough on its own? Frustrating, I don't have a simple yes no answer to this question. The unfortunately answer, it depends. And in this lesson, we're going to dig into these questions. So we'll explore some of the history around what Redux is, why it is being useful, and how things stand alone. I'll also share the formula I use when deciding how I want to manage state in my application. Some background info. In the early days of React, it was expected that React will only be one piece of your front-end task. The best practice was to combine React with some like Flux, Redux, or mobs, state management, but only on the local state. Specifically, the idea was to use React for local states and the tools like Redux for global states, right? So local state is the state that is only needed in one particular part of the application. So most of the examples I have seen in this model have local states, right? So for example, in a form, in a list, showing some animation or triggering some animation, but in that particular component. So things like how many times you have clicked the Tony, of what the current value is of a control text input. Exactly, or a control text input. Global state, and on the other hand, is for broader things. So for example, data about the current logging users, or maybe the analytics, or maybe the current selected color themes. A single piece of global state might be used in dozens of different corners of the application. The line between these two categories can be blurry, and it is more a spectrum than a binary choice. The thinking was that React state was well suited for a small, simple piece of local state, but it wasn't powerful or flexible enough for a global state. It was too difficult to move a state variable across the application, and it was hard to orchestrate complex state change. From 2014 to 2016, a number of packages were competing to be the global state partner for React. In the end, the undisputable champion was Redux. Intro to Redux. It is difficult, and it was in 2014 and in 2016. Intro to Redux. It is difficult to describe Redux without going on a huge tangent, but I will do my best to summarize it quickly. In Redux, our global state is represented as a single object that floats outside of React application. Okay? This state can directly edit. Instead, Redux listens for actions, events that signify that something happening in our application. So this is how you can describe now this Redux without going into the tangents. It's like Redux is our global state that is representing a single object that floats outside of our React application. So that state can be edited. So this state can be edited directly. Instead, Redux listens for actions, events that signify that something happens to an application via the Flux architecture, right? When you have now the actions and the Redux, so you can mutate that state manually. Redux Redux listened for actions, event that signify that something happens in our application. All of the actions are meticulously logged by the Redux. And can almost be read like a story to understand what's going on in our application. Because now Redux is this particular library that meticulously log all of these actions. We can almost be read like a story to understand what's going on in our application. Pretty much like Git here. Right? So all of this is because we didn't have any state management back then. For example, the log for an e-commerce app might look like this. Users log in, users submit search forms, search results received from server. Exactly. Users log in. This might be one action. Users submit search form, search result received from the server. User click on page 2 of search result received from server. User add Hello Kitty coffee machines item to the cart. Each of these actions fires through Redux, and we can write some code that controls how this action should affect this state. So for example, Here's how we might process that exactly that last add items to the car actions. So you define now a function that is going to receive now the actions, the state and the actions, right? And then based on that action, okay, u1 is to now define or yeah, exactly. So you're now going to generate a new state that is going to be now returned that. So you are generating a new state out of this. Like in React, state update in Redux are immutable. In fact, Redux state has a lot of in common with React state, but Redux give us additional superpowers. This is quite interesting here, yeah. So the state React state has are like React state updates in Redux are immutable. Okay, so you need to recreate a new state of this. But Redux gives us additional superpowers. The Redux dev tool, for example, has a feature known as single travel debugging. We can step through Redux meticulously log of action and inspect the UI at each moment in time, rewinding and pausing. Redux is the ultimate detective tool when it comes to debugging. And Redux is incredibly customizable. It offers a bunch of additional APIs like middleware and stone enhancers to extend what Redux does out of the box. As a result, there is a rich ecosystem of Redux add-ons. Exactly, and Redux is incredibly customizable. It offers a bunch of additional APIs like middlewares and store enhancer. So middlewares and store enhancers, specifically middlewares, are now things that we want to now trigger that for async updates. So you don't define your async updates in these actions, in this function here. And to extend what Redux does out of the box, as a result, there is a rich ecosystem of Redux add-ons, tools that make Redux even more powerful. But all of this power and flexibility comes at a cost. There is a significant amount of friction when using Redux. Everything takes a bit longer and requires a bit more code because you have to scaffold out of a bunch of stuff. The number one complaint about Redux is that there is too much boilerplate. It also has a pretty steep learning curve. Redux leans heavily on functional programming principles that takes a while to wrap your mind around. Relevance in modern React. So it was considered a best practice a few years ago to use Redux to manage global state. But how do things stand today in the modern era of modern hooks-based React? Is Redux still relevant? This is a controversial question and something that still gets debates a lot in the community. There isn't a wide accepted answer. Some say that Redux is as useful as ever, and it provides tons of sophisticated tooling and insights. They'll point to the npm download numbers, which shows that Redux is still growing in popularity. On the other hand, on the other side, folks with points that React has evolved quite a bit in the past few years, and it becomes much more capable on its own. It is even integrated some of Redux features like use reducer hook. Modern React offers most of the benefit and none of the drawbacks. Interesting, Redux was created by Dan Abramoff and Andrew Clark. Both of them now works on the React core team and have distanced themselves from Redux. Here's what Dan says about when he will choose to use Redux. I struggle to think a case where I want to use it myself. Here's what I think. Both group makes good points, and I think they are both right in their certain context. but it really depends on the type of application we are building. So if you're building an application that is, you're building a corporate application, all right, you want to go is with well-established industry standards, not with some random library that are written for some folk in a basement at their home, right? Because it's going to impact now the business operations. So French toast, no. French toast, no. No. My own bias. I'm going to elaborate on my viewpoint, but first I want to share a bit of my personal history with Redux. I was early adopter with Redux. I started using Inside Project when I was brand new, and I friggin' love it. Once I got the hang of it, it felt so elegant and delightful to me. I worked with Redux on multiple jobs, including Breather, Unsplash, and Khan Academy. I have also built a lot of side projects using Redux. For example, a few years ago, I created a bitmapper, a 3D level editor for VR rhythm game Beat Saber. New updates. And delete and go on. Oh, it was way too okay. You can snap to And it is using is React and all that kind of stuff. No, it's not using React, it's using just 3GS. Damn, son. BSMG. Okay, in any case, coin market cap. Oh crap, I closed by mistake. There you got it. Coin market cap. And the web service tangent. Coin market cap. Okay. So this project used Redux extensively, and I believe it helped quite a bit in terms of keeping the applications maintainable. Because now you can keep all of the different state here. Exactly. Let's say I have a lot of the projects that don't use Redux. This course platform, for example, don't use Redux at all. Neither does my blog. For me, whether or not to use Redux depends on the specific application type. Exactly. Not much states or landing page. There is only React. Mostly client side, React. And mostly server state, I think the clearest past example is the analytic dashboard. We have a bunch of complex data in the database and our app fetch data and passing it to the user. These applications are essentially interface that lets user read and manipulate data that live in the database somewhere. This is a broad category most crew apps fits into, including most SaaS applications, social network, search engine, and e-commerce sites. Alright, now that we have defined this category, let me talk about why they matter. The right tool for the job. And here's what we're describing is this. For most static website, you don't need to rely on Redux, right? However, for client-heavy applications in category 2, for example, like Latam or a bank, for client-heavy applications, Redux is a great candidate. I wouldn't go far as say that it's necessary, but React really has become much more capable in past few years. But it's still a very helpful tool. Redux helps keep the code simple even as the feature become more and more complex. And it has a lot of built-in performance optimizations. Things get interesting when we talk about the server heavy application in category 3. The biggest state-related challenge in this category are all network-related. Fetching the right data at the right time. Making sure the data doesn't grow stale by revalidating. Fetching again and customizing the revalidation for the specific situation. Catching the data so that the multiple components don't repeat requests unnecessary. Optimistic UI updates so that we predict how network requests will resolve. And the other is paginations. But this exactly, for example, React Query and SWR. We'll learn more about them in Module 3. If you're building a video game or an audio editor, Redux is great, but most of us aren't building those sort of applications. I guess that 95% of the real applications are either category 1 or 3. So this is the mental model I use to figuring out which tool to use. If it is a static website like my blogger, I use React alone, with the help of context discussed in Module 4. If it is a client-heavy application like Beat Saber Level Editor, I use Redux for global state. If it is a server-heavy application like this course platform, I use React plus something that helps me do with network stuff. So for example, SWR. On this course platform, I have no complaint. I'm using Vercel SWR for this, but to manage is network stuff. Lightweight, real-time, suspense, pagination, backend agnostic, SSR, TypeScript ready, and remote plus local. The name stale while revalidate is derived from an HTTP cache invalidation strategy popularized by this RFS. It's a strategy to first return the data from the cache stale and then send the fetch request revalidate. It's a strategy for first return the data from the cache stale, then send the fetch request. Okay, first return the cache from the data, then send the fetch request, revalidate, and finally come with the up-to-date data. Stale, fetch the data from the cache, stale, all, then send the fetch request, revalidate, and finally now come with the up-to-date data. With SWR components, we'll get a string of data update constantly and automatically, and the UI will be always fast and reactive. Exactly. Use is because it's that particular who fetch this data from the cache stale. Okay. First, return the data from the cache stale, then fire the request. Okay. Then send a fetch request, revalidate to the server. Okay, this is the different phases, and then finally come up with the up-to-date data here. In this example is this: if there is an error, return the fail to load. If this is loaded, return the loaded, and if not, return this data here. Okay. But it's made by Vercel. But it's made by Vercel. Design engineer. CTO of security. Mm-hmm. 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 Interesting, interesting. State management here. I'm using Versal SWR on this core platform and I have no complaints. This is the formula I have found work best after years of experience and dozens of projects, but a lot of this really does comes to subjective preference. But here's something I can say pretty objectively. React has evolved tremendously over the past few years and has become way more capable. And you can absolutely build large, sophisticated application without any other state management library. You don't need Redux. and you shouldn't feel pressure to learn it. If you're new to React, here's what I suggest. I spent a year or two getting comfortable building apps with React. Using the tools to cover in this course, you can always explore Redux in the future and see if you find it helpful. There is one more wrinkle about to talk about, Redux Toolkit. Over the past few years, the Redux team has been hard at work creating Redux Toolkit, an opinionated toolset that aims to sand down some of the rough edges of working with Redux. This toolkit includes a project RTK-Query, a tool which is more or less a Redux compatible version of a React query, SWR. I will be pretty excited about this development, but unfortunately I have fundamental disagreement with the opinions that are baked into Redux Toolkit. I'll share my queries below for anyone curious, but the takeaway is that I apply and continue to use classic Redux without Redux Toolkit. I already use Redux Toolkit. I think it's because the boilerplate that is used, rather than trying to get Redux and SW to play nicely together. I think RTK query is a slam dunk, and it makes way more sense to use something tightly integrated rather than trying to get Redux and SWR to play nicely together. Otherwise, it is hard for me to say whether you should use this combination over something else. I wouldn't be my first choice. But as I say above, there's a lot of great options nowadays, and this one might work best for you, depending on the type of app you are building on a subjective preference. In Redux, there are two distinct concepts: actions which track things that happen, actions which track things that happen. Users submit form, a timer expires, a network request exactly, and Reducer, which responds to actions by changing the state in some way. In classical Redux actions, we were made semantically distinct from Reducer. It was seen as a bad thing if your action has set in the name, so set user data, because actions are supposed to describe events, not detect what those events affect. Exactly, because actions are supposed to describe events, not detect what those events affect. The reducer is the one who decides what impacts the actions has on that state. Exactly. This clear division of responsibility, in my opinion, is the secret sauce, because it's the reducer that is deciding what impact the action has on that state. The thing that makes it great, a single actions like logout might affect the user reducer and also the season reducer. We can watch the stream or actions to get bird's eye view of what's happening in our app, and we can consult with reducer to see the impact of action. In Redux Toolkit, actions and reducers are grouped together in slice. For example, a shopping cart slice will combine both the reducer branches that change the state and the action. Each slide has its own exclusive actions, and as a result, actions has become glorified state setters rather than being broad description of the event. As a result, action has become glorified state setters. But if the action described is the what has happened, and the reducer is what the state has, they are now using as the actions to defining as a state setter rather than being broad description of the event. This probably doesn't sound a big deal, and it is impossible for me to explain if you haven't worked in large classical structured Redux app, but honestly it is utterly at odds with how I think Redux should be used. I will not using Redux in this way. I do not understand why Redux team has made this change. As I mentioned, the number one complaint about Redux is too much boilerplate. But consolidating action and reducer, it means the developer doesn't have to hop between actions and reducers filed and they spend less time writing code. But here's a question: is this boilerplate really that bad? When I work at a Khan Academy, we use Redux, and honestly, I didn't add much value for us. We didn't have tons of global client state, and also it feels like we were spending too much time on Redux boilerplate relatively to how much value we were getting from it. When I work on an app with a lot of client-side state, however, the boilerplate is absolutely trivial compared to the amount of benefit that I'm getting from Redux. It's not even closer. But a big part of why Redux is helpful is a crystal clear event log. By squashing actions and reducers together, we send away one of the most useful part of Redux. And also, I'll continue to use classic as it is. But I think this is what he mentioned about this. Iterative control examples. Valid language.map. Exactly. If your mapping is this, because otherwise, here is your shadowing. You can rename this. You can rename this. I to say option. This is known as shadowing, and it is essentially means that we have lost access to the outer language value. For this reason, I like to use the generic option name when iterating over possible options. The same for this checkboxes. As with radio buttons, the check property, which is here check, the check property is used to create a control exactly with the same with the name and the ID. HTML4 opt-in and the ID. So that's going to map each one of those elements, all right, and iterate through those topping here. By iterating through this map, you have the object of keys of that. When you have now these keys, anchovy chicken in here, all right. And then if you want to iterate through this list of collection, hey, if this options now is true, okay, hey, on chain, I'm gonna now is set this state with pixel toppings and the initial toppings. So you're gonna recreate that particular object here, passing whatever pixel topping I do have here, passing whatever pixel topping I do have, and if that particular option match that, then I'm going to check this. And the label HTML4 is the option which is the same as the ID. So if it must match one of these options, you can create is this label and the ID. But it changed the string. Yeah. I don't think that this will work. No. Okay, so that'll be all for this video. Take care. Bye bye.